Alright, hey guys. So unfortunately, I won't be able to make the class on Wednesday. But we're going to do the content now. I do want to mention to you that most of the time you should be working on your assignment. This is going to be your only class really dedicated to most of it working on your assessment. So please take advantage of that. Get lots of work done. You've got a lot of work on your assessment. You should all know exactly what to do. I did get a question about project description. So if you remember the template that I sent to you via Edmodo, if you've forgotten that, it's on Edmodo. Just project description. Just give one sentence on what your project is. Just very straightforward. You're not getting marked on your project description per se. Just good to. We're trying to build that structure of how people do this in industry. Okay, we don't want this just to be an assessment. This isn't, I'm going to get into trouble, but this isn't Shakespeare. Okay, this is serious, serious work we're doing that should assist you when you do go out into the big world. So let's get started. We're going to go through this. I will upload it later, but you're going to go through this with me. What is data? Now, we've spoken a lot about this, and I've got my whiteboard here. If I was to show you this here, 1010110. Now, because you don't know what that is data. It is raw, it is unprocessed, it is just input. That's what it is. The moment you understand the data, the moment there is meaning behind it, it turns into information. All right, so capture that. So data has no meaning by itself as it has not been processed. Example, when using a calculator, the individual numbers don't tell us anything until we add a process, subtract, divide, add, and retrieve the output, the calculation. When data has been processed and interpreted, it is known as information. All right, so that's really important to understand the difference between data and information. What is data? Now, I just gave you that example of 1010110, but what is the smallest item of data can we get to? Can the letter A be data? Can a zero be a data? And the answer is yes. Each character is represented by 1 byte of binary data, zeros and ones. The combination of zeros and ones used to represent a byte of data is usually 7 or 8 bits of ASCII code. Alright, so the way computers input data and the way that your computers understand what's going on is with binary. They don't understand, make my character blue or something like that. But what they do understand is binary, and all binary is 0 and 1. Now, think of 0 as off and 1 is on. You can only have two states, off or on. It's either on or it's off, and that is binary. Okay, and binary can be interpreted by many different things. Your graphics card will be able to interpret the binary differently than your audio card, which makes sense, doesn't it? It turns that data into music or something else. Okay, so we're going to learn about binary today. Programs interpret binary data. A computer has no understanding of the concept of bit or byte, data type, or structure. The programmer enters the data into a translator and writes a program in a programming language to use and manipulate the data. The rules that apply to the manipulation of data vary between programming languages. Data can be various types: letters, numbers, lines, such as on a graph or a picture, or symbols. These data types have special names in computing. Each program uses a particular type of data. All data is two basic types. It's either a constant or a variable. So we've used variables, haven't we? And you should be able to kind of get understanding what those two basic types are. Variable changes, okay, we can change it. So we can change the movement speed. Constant would be something like gravity. We don't want to change the gravity in our game. Okay, so in our games, we've been learning about integer, floating point, string, boolean, date, and currency. Not so much currency. Sadly, we haven't added in-app purchasing yet. That's for week 10. But an integer is a whole number: 1, 2, 100, 150. Now, floating point, if you're not familiar with that terminology, is just is when you use a decimal place. So 10.4 is a floating point. 105.3298 is a floating point. String is just test or hello world. It's just a series of characters. Boolean is true or false. Date is the date, and currency is a monetary value. So we use different data types for different type of data. All right, we're going to talk now about binary, and we're going to jump away from the PowerPoint very soon. So binary, so we've got binary, decimal, and hexadecimal. So our system of counting is decimal. We count by tens. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? My daughter counts very differently. She starts with 1, but technically with decimal we start with 0, okay? Because 10 is just it is now moving into 11. 0, 1, 2, 3, 4, 5, 6, 7. Anyways, so why you might be wondering, why do we start with 0 instead of counting 1, 2, 3, 4, 5, 6? Well, 0 is, think of an array. All right, let's think of an array. And if you don't remember what array is, it's a list. Let's think of a list, and it's got the months. Okay, so list is the is the months of the year. Okay, so I'm just writing this very basic. Generally speaking, when we are doing arrays, there will be open square brackets and close square brackets. Okay, so Jan, June, July. I'm not sure why I did that, but I did. So in our array, we have 3 indexes. We have January, June, and July. Now we start with 0. This is 0 here in programming. If you were to say month, if we were to try, here's some Python here, print month 1, like that. If we were to go print month 1, it would print this one here, because that is 1. So just remember, when we are talking about computer science, when we're talking about software design, we count by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you count with a 4-year-old, it is different. We count, 1, 2, 3, and even generally we count 1, 2, 3. We don't count, how many apples do you have in your basket? 0, 1, 2, 3. It's 1, 2, 3. But in computer science and software design, just remember 0, 1, 2, 3. And you will need to just remember that, because normally when you go to your day-to-day life, you do count 1, 2, 3, 4, 5, 6. Okay, so binary is 0 and 1. Okay, and it's just on and off. Okay, And then we have hexadecimal. Now, hexadecimal is hexa is 6, 10, des is 10, so it is 16 numbers is used. It's binary. Hexadecimal is easier for humans to understand than binary. Okay, you've probably seen some hexadecimal in the format of colors. If you used Photoshop or something else, you'll have seen maybe 0, 0, F, F, A, F. Oops, hexadecimal. Sorry, just give me 1 second. Hexadecimal 0, 0, F, F, A, F. Excellent. And it's all smudged. Okay, let me try again. So with decimal, we go 0, 1. I'm just going to go 0 to 9. With hexadecimal, we go to 0 to F. Now, you might be thinking, what does that mean? Well, we go, again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we don't go to 10. That's not how we represent, that's not hexadecimal. We go A, B, C, D, E, F. Okay? So that's hexadecimal. Very straightforward. Now we're going to look at how can we convert binary to decimal and vice versa. We'll do hexadecimal next week. So the way to do that is, let's say we have 2. We have 1, 0, and binary is written as 2. Or we can just do 1, 2, 4, 8, 16, 32. Now, with binary, it's very easy. It goes up by the power of 2. So 1, 2, 4, 8, 16, 32, 64. You probably learned this a while ago now. 64. Oh, smudging so bad. 128, 256, 512, and so on. 256, 512. Okay, so we have currently a binary that is made up of 2 numbers. So the way we do that is we put the 1 at the 2 and we put the 0 at the 1. So we know that equals 2. Now I want you to make sure that you're doing this with me, because converting from a binary to decimal will be most likely in your exam. This is something that you should be able to do in your exam without a calculator. It's really easy stuff. Let's do a different one. Let's go 1, 1, 0, 1. Okay, 1, 1, 0, 1. Well, we are going to start. This is our lowest number here. Okay, this is our lowest one. So this is, where should this go? This should go right here. I'm going to rewrite this so that you can see, but no, I think that should be all right. Yeah. And then we put the 0. Well, that's a terrible 0. And then we just add them up. So 1 plus 4 is 5. Then 5 plus 8 is 13. So that's 13. Let's do another one. Oh, I've lost it. So it's really easy. I hope you're seeing something that's pretty easy to do with binary. Let's do another one here. Let's do 1, 1, 0, 0, 0, 1, 0. 1, 1, 0, 0, 0, 1, 0. Well, let's do that. So let's just count again. We'll count with 1, starting with 1. 1, 2, 3, 4, 5, 6, 7. So that's 7 there. So let's count here. 1, 2, 3, 4, 5, 6, 7. So we're starting at 64. And what's first is a 1. And there's another 1. And then we've got 3 zeros. 0. Whoa. This is a terrible 0. Then we're going to 1. And then we have a 0. So we just add all of that up. 2 plus by 32 is 34. And then 34 plus by 64. Anyone can do the math really quickly for me? You know, like Dora the Explorer. What's 34 plus 64? Great work. It is 98. 98. So that's how you go from binary to decimal. Let's just do one more, just to make sure. And I'm not going to tell you my answer straight away. I'm going to give you a little bit of time to figure it out. Okay? Are we ready? Here we go. So 1, 1, 0, 1, 1, 0, 0, 1. Yeah, let's do 8. Or a byte. So 1, 1, 0, 1, 1, 0, 0, 1. Try doing that now. And see what you come up with. I'm going to do this very quickly. Now, I'm not entirely sure why I just told you to... It's probably because it's 10 o'clock. It's been a long day. It's been a long month. Good month, but a long one. So let's, instead of starting backwards like here, like I did, just put this one here. Alright, that's all I'm going to tell you. I should have started with that. And I'm not going to re-record this. Because I've got... But there's many different ways to do it. Just make sure you get there. Now, I am going to do math with my calculate with my phone. I'm hoping you guys' math is so much better. It is past 10 o'clock for me, and that means my math is not as good as it is when I have had some rest. So your answer should be 16 plus by 8 plus by 1 is 272. 217. We are going to do a Kahoot on this. I expect you all to be able to do this. Really easy stuff. 217. Now you see, we got 217. We could not be getting 256. Let's try again and see what answer we get when we go 1, 1, 1, 1, 1, 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1. Okay, so just 1, 1, 1, 1, 1, 1. 8 times. Okay, so try again. I'm going to give you a little bit of time to do the math here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. All right. So what is 1 plus 2 plus 2 plus 4 plus 4 plus 8 and so on? So what do we get? We get 255. If we were to get 256, what would 256 look like in binary? Well, it wouldn't look like this, would it? It would look like it would have 1 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. It would look like that. 1, 0, 0, 0, 0, 0, 0. Okay? So hopefully you're starting to understand that. How long has this video been going for? 20 minutes. All right. Now let us do it the other way round now. How do we go from 40? Let's do an easy one. Let's go 3. How do we get from 3 to binary? Now, 3 is an easy one. You can probably do it in your head. Okay, but let's do it together. So we still write 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. Now, 3. So we do this differently. I'm going to show you just something, this one example, and then we don't do this again. Okay? But we find 3. So we look at 3, and we look here as well. And we go, okay, is 4 bigger than 3? Well, it is, isn't it? 4 is bigger than 3, so we add a 0. Now, is 2 bigger than 3? Well, no, it's not, is it? So we add a 1. Then we subtract 2 from our original number, our 3, which gets us a 1, and we put that as 1. So we know that's 1, 1. Now, why don't we add 0 before here? Well, I mean, we could, and we actually do in bytes, and it would look like 2, 4, 6, 8. It would look like 0, 0, 0, 0, 0, 0, 1, 1. But, yeah, that's right. Yes, so we don't need to do this, okay? It's just like adding in, if we talk about decimal 35, we could put in all the zeros in front of it, saying that it's not $1 million, you know, saying 0.000000035. It kind of reminds me of that Ali G clip where he's asking some scientists if a calculator can do what's 10 10 10 10 10 10 10 10 times by 10 10 10 10 10 10 10 9. It's a funny clip. I don't know. Maybe you guys are a bit too old for that. Young, not too old. Now, let's do something a bit trickier. Let's go with the number 45. Okay, so we've got 45. Now, you should be following on with me. Okay, I'm not doing this in an interactive style just so that I can do math at 10 at night. I love doing math. Don't get me wrong, but this is for you. Okay, this is for you. Now, is 64 bigger than 45? Well, it is, isn't it? So we don't start at 64. Is 32 bigger than 45? No, it's not. So we add a 1. And then we subtract. I'm going to do it on my calculator so that I don't embarrass myself. Now we get 13. Okay, so we go 45 minus 32 is 13. Is 16 bigger than 13? It is, isn't it? This time we add a 0. Is 13 bigger than 8? It is, isn't it? So we add a 1. And then we go minus 8. So 13 minus 8, you should all know what that is, and it is 5. We just did it, didn't we? Okay, so is 5 bigger than 4? Yes, it is. So we add a 0. Then we go 5 minus 4 equals to 1. 1. There we go. It's so easy. It's so good. I was creating an ancient Egyptian math game for a client of mine, and the way the ancient Egyptians did multiplication and division is identical to the way we do binary. I might send you the link if I can remember. You might need to remind me. But it's incredible that the ancient Egyptians did binary the way we now do it in class, with understanding how to convert between binary and decimal. Anyways, let's do a really hard one here. Let's do a really hard one. This is 2, 6, 1. 2, 6, 1. Now, I'm going to let you do that now. I'm going to let you do that. And then I'm going to see if your answer is the same as mine. Okay. So 261. $261. All right, so I'll give you guys just a little bit longer because this. Actually, just pause it. You should just pause it if you need some more time. Oops, it's not that one. Made a mistake. Oh, 1, 0. All right, so the answer is this. All right, so 261 is bigger than 256, so we add a 1. We then subtract 256 from 261, which is 5. So we then go 0, 0, 0, 0, 0. Then we hit 5 is bigger than 4, so we hit put a 1, subtract by 4. We then go to 1. Super easy. Isn't this beautiful? Isn't it just really easy? Something that you thought was going to be really complex, something that you thought you were going to have to study for and try and figure out the complexities of computer science. And don't worry, there's plenty of that. This one is easy, which is great. Now let's do one final one together. One final one together. I don't even know if this is going to be easy or not, but 798. Oof, isn't that tough? I'm going to give you time to get that done. I'm going to use my calculator just because, again, it is past 10, which means my brain. I've just had coffee, so you'd think that I'd be operational, but not so well, not so much. All right, are we almost ready? I can just hear people just saying, "Oh, sir, give me 1 more minute." All good. Take your time. That's what I would say. And it goes 1, 0. All right. So the answer is 11000111110. And you feel free to find a checker if you don't trust my math. Hexadecimal to binary converter. Is this going to work? Okay, enter decimal. So we just did 798, 798, convert. So it's 110000111110. Isn't that awesome? And you can see what that looks like in hex. But we're going to do that later. Don't worry about hexadecimal today. All right, so that's a good place to end. I think I'm going to leave. I guess I can just, give you some more homework. I'm not going to make you do notes, but I am going to make you do this. 1. So convert to decimal, convert from decimal to binary, and then do these 2. That's your homework. Or actually, just do it now. It's not much. Convert from decimal to binary. Let's do another one. Let's do 984 and It's still a tricky one. Let's see how well you guys can do it. 1,026. No, make it harder. 2,439. Now to convert from binary to decimal. Convert from binary. Let's do a hard one. Just do 8 bits to begin with. 1 0 1 0 1 1 0. How many is that? 1 2 3 4 5 6 7 8. And then B, we're going to do 1 1 1 0 0 1 1 0 1 1. Yeah. All right. So just do that. It's awesome. I mean, you've been working with data types, and we're just going to continue working with data types. So I'm expecting you guys to know everything else. Work on your assignments. We're not going to do any new theory today, any new extension of your Unity games. Work on them. Okay, so no more. I said we might be learning about shaders, and I think it's a good time to just to take note of what you have done, which is amazing. You guys are absolutely amazing, and just work on your assessments. Okay. So send me an email if you have any questions, and you guys are absolutely terrific. And don't forget, next week we're doing 2 awesome workshops at UTS, Animal Logic and the UTS Game Studio. So make sure you're here next week, which is the 16th of June. All right, thanks guys. 16th.